Okay, great, folks. Okay, so we're going to go ahead and kick off in the field safety book, okay? We're going to go ahead and we're on Roman numeral 8 and page Roman numeral 8, page Roman numeral 9. What we're looking there is the contents. Those are 9 modules. We're going to push out the longest one. I'm going to let you know now. It's about double the length of any other module is module 1, okay? So we're going to push as hard as we can on module 1 tonight. And the good thing is that this book already has a lot of pictures in it, so we'll go ahead and kind of be able to do maybe a little bit less on the internet and kind of hit more textbook, okay? In addition to that, I'm going to show you where all the tests are and everything right now, so I'm going to walk you through this book really quickly, okay? All right, folks, so this is the thing. This book, if you notice, kind of thumb through the bottom, and you'll notice it doesn't have traditional page numbers. This book, what it does is it actually winds up having page numbers for each module. Okay, so you have module 1, and then it'll run page numbers, I think like through 60 or something like that, or 65. Then you'll get into module 2, and it'll wind up running probably another 30, 35 pages. You know, same thing on and on. Okay, module 3, it'll probably be about another 20, 25 pages. So, like I said, the longest module is module 1. This is going to be the roughest push tonight, okay? Just to kind of give everybody a heads up. All right, so if let me just cover the 9 modules that will be covered, and then we'll run into module 1. First one's going to be Intro to Safety. You're going to see there's going to be a lot of different information in Intro to Safety. Okay, module 2 will probably start hitting either Thursday or next Tuesday, which is Confined Spaces and Excavations. And then work zone safety. We're talking about a lot of like traffic cone devices, flagging, stuff like that. Electrical safety will be 4, and then working from elevations like scaffolds or elevated work surfaces and ladders is 5. 6 will be steel erection. 7 will be heavy equipment, forklift, and some crane safety and rigging. And then ultimately number 8 is concrete and masonry work and hazards. It'll be a lot of like rebar forming, some concrete pouring, silica hazards. And then ultimately, and the last of all, is module 9, which is Introduction to Hazardous Materials. We'll kind of talk about a little bit of transporting and rigging and stacking hazardous materials. So let's go ahead and go. Do something for me, and would you please go to module 1, page 1. And when you get to module 1, page 1, what it'll look like is it'll have section 1 on your left-hand side. It'll be all green column all the way down, and then just a little bit of green on the top column or the right-hand column, okay? All right, so I'm going to show you a few things here, folks. Now, let me show you what happens. We're calling them modules. The way that the answer keys come when I send them to you, it'll have. Let me show it to you as a matter of fact right now. Okay, let me go ahead and show you the answer key while we're talking. Okay, this is what you'll have some of these in the back of the book already, and let me show you the one that I'll be sending out to you a little bit later today. Let me see where it is. Okay, here you go. This is what I want you to see. Okay, this will be the answer key that I'll be sending in PDF form. And let's see, 1 second. Okay, so now let me pull it up for you. Okay, folks. So this is. Can y'all see? Can y'all see that? All right. Can you see that all right there? Good. Okay. Good deal. Okay. So this is what we did. Right? Is if you look, do something for me. If let me walk you through a few pages. Okay. For those of you that weren't here last week, go to module 1, page 7. You'll see 2 questions in green there. Okay. Now you're going to go to, let's see, I think it's page 9 or 10. Let me see. It'll be page 14, 15. You'll see 2 more review questions in green there. And then let's see, I'm going to take this to one more section just so you get an understanding. Section 3 is going to be on page 22. They have, I'm sorry, I skipped a section in there somewhere. Page 19 is going to be section 22. Section 3, I'm sorry, of module 1. and then page 22 is section 4. Okay, so what'll happen is this: is that as you're going through these tables, let me show you the answers for anything in green that you have. Let me give you the page number for it, and I'm gonna walk you through what's in this chapter. We're gonna start cruising through it. Okay, let's see. Go to page module 1, page 67, and let me know. Just type in the 67 once you get there. That way I know. Okay, good. It looks like most of y'all. Okay, good. Y'all are getting there. Okay, good. Okay, so this is what will happen with page 60. This is what will happen with this page 67. Page 67 is all the answers to the green sections. Okay, so as you're working through the test, you already have all the questions to the green sections. Not only that, you also have the section of review that it's in. So you'll notice as we go through tonight, all the paragraphs are numbered. Okay, all the sections are numbered. So it'll show you where the section is, and then the objective will just be in the front of the book. I wouldn't necessarily worry as much about the objective. Okay, I'm more concerned about the reference section. So if you don't have the right answer when you answer the question, or if you need help answering the question, come back here and look at the section review. Okay, and that'll tell you where it is. Okay. So that's for all the green questions. Now, if you go back to page 59, these questions that you see there, if you see on page 59, you see 25 questions on page 59 and 60. Those questions on page 59 and 60 are the 25 questions that are here on the sheet that I've got on the screen right now. That is module 1. Okay, these are all. This isn't the test, y'all. This is just end of chapter questions. Okay, so I'm going to ask you to do either one or two things. If you want to answer them if you can. If you can't, and then if you look at right here, let me pull my cursor up right here. These are the module numbers or the section numbers where in that module the answer is located. Okay, so let's say if you don't know the answer to number 7, it's going to be in section 2.1.1. Okay, if you want to get to the answer. Now, if not, here's the answer, B. And then, of course, you go in there, look at B, and at least at a minimum, I want you to be able to have 25 answers by the end of the chapter, okay? There's no other chapter that's that long. I think every other chapter is 10 questions or less. So, like I said, the longest chapter that you're going to have during this whole training is going to be this chapter 1 in this book, okay? Okay, so let's roll with it. Let's go to module 1, page 1. And let's talk about a few things, okay? Now, I'm going to tell you, there are a couple of things in here that I'm not necessarily in agreement with, and I'm going to tell you, and then we're going to talk about NCCER for purposes of NCCER testing, okay? So this is what I'm going to do. Let me walk you through what I'm going to do. We're going to concentrate on anything that's in the green tonight. We're going to concentrate on anything that's bulleted. We're going to concentrate on anything that's numbered, okay, or anything that's got bold wording. All right. And then, of course, all the pictures. Anything that you see in purple is more tidbits, more for kind of like Q&A. Did you know? Anything that you see in the darker tan is going to be more like kind of questions you may ask yourself or at work. And then anything that you see in cream is going to be case studies, okay, or case history. So you can always read those at will. But like I said, I'm going to cover the meat of the standard, okay? So let's go ahead and talk about it, right? So let's talk about the key terms or the trade terms in this section. So so the definition of an accident. I'm telling you, let's get accident and incident out of the way, even though they're out of order, and it's because I don't necessarily agree with their position on it, okay? An accident, an unplanned event, okay, preceded by unsafe act, unsafe condition, right, or both, which disrupts activities and often results in personal injury or property damage. Okay, so that's going to be an accident, and an incident is an undesirable loss of resources or undesired event that under slightly different circumstances could have resulted in personal harm or property damage. So let me explain this, okay? They pretty much, NCCER by they, pretty much compares an accident to where there's personal injury or property damage. An accident, excuse me. An incident is they compare it to there wasn't personal injury and there probably wasn't any significant property damage, okay? Now, I'm going to tell you, from the oil and gas industry, and y'all correct me if you're wrong, and I want you to weigh in and tell me which options, right? Either the NCCER option, or let's call the other one oil and gas, right? That really accident versus incident is more that an accident is something that was unplanned. something that was unplanned, that also may have been unpreventable, whereas an incident could have been prevented. We had a bad practice, right? We didn't correct a condition to begin with. Maybe we had let me use an example, right? Then maybe we had a saw that we knew that was already having electrical malfunctions, and all of a sudden we still choose to use that circular saw, and now an employee is shocked. Okay, for me, that's an incident because it could have been prevented. An accident is the saw just malfunctioned. We did everything. Maybe it was brand new, right? Maybe it was brand new, and then for us that may have been an accident because it was non-preventable on our end. Okay, so now let me compare it to law enforcement and to traffic accidents. Okay, um, how many of you have noticed that now, like state police, state troopers, and even government officials, they rarely ever use the word accident anymore. They usually say, like, let's say it's a car wreck, right? Or multi-car crash or something. They use the word wreck, crash, incident, okay, occurrence. But you never really hear them use the word accident anymore on TV. Have you noticed, or on the radio? Has anyone noticed that? Okay. And and the reason is because accidents could have been prevented. Okay. You remember when we were little kids, right? You break something. What happens when an adult says something? We say, "Oh, it was an accident." What's the first thing they say? There's no such thing as accidents, right? Okay. Kind of the same thing. Maybe didn't know why they were saying it, but kind of the same thing. Okay. So this is what I'm going to tell you. We're going to move on from it. Okay. If anybody wants to chime in, chime in. I'll read your comments. Okay. Is for my personal opinion, and I think oil and gas, an accident could have not prevented. It's something that was probably non-preventable. An incident is injury, illness, damage, fatality, whatever, that could have been prevented. All right. Now, as for NCCER, and now for testing purposes, let's talk about this. Okay. Okay. So who agrees with that statement, the one I just made, as opposed to the NCCER position? Accident could have been prevented. Incident could have been prevented. Accident was not preventable, and that's why we call almost everything incidents now. Is that fair? Okay. Okay, so most of you agree, okay? Okay, now let's talk NCCER because of test. Okay? An accident includes personal injury or property damage. Okay, an incident is more of a near miss. Did not have uh, uh, personal injury and probably had very little property damage. Are we okay with that? Okay, good. Okay, so let's move on. That's the most confusing thing of the night. Okay, I promise. And look, folks, we're gonna be doing some test review. You know, the questions in the back of the book you're gonna answer according to this. Okay, but when we do some test review, we're gonna do it as well. And then after the test, we're gonna do a little bit of remediation, go back to our original mindset. Okay, all right. Um, And then, of course, best practice plan. What are we talking about? Something that we're going to include best practices available, equipment, right, to make sure that we employ safe work practices for the employee. And then competent person. Who's a competent person? This is who the competent person is going to be, right? It's the person that's capable of identifying and predicting hazards. And ultimately, and this is what I want you to know, is that they have the authorization to take prompt corrective measures to eliminate them. So they have to be qualified in their job to do what they do. But ultimately, what makes them competent is they have to have the authority to take prompt corrective actions in order to minimize or eliminate hazards. We okay with that? Okay, good. Okay. All right, prompt corrective action, right? Okay, and then compliance, right? Things that we know, right? That we're actually meeting the safety standards or we're meeting the proprietary consensus standard. Um, and then OSHA, we all know who OSHA is, right? U.S. Department of Labor, protects our safety. OSHA standard, I think everybody on the line, we're all in agreement with the OSHA standards, right? That basically the OSHA standards, you know, what are they, right? Is that it's a standard adopted by OSHA, right? That requires conditions or us to adopt certain practices or safe practices, methods or processes that it's going to ensure employee safety, right? And I know I see a couple of y'all have never taken the 510 or at least not taken it here yet or with me, but just remember this, y'all, anybody who's newer on the line, an OSHA safety standard, each standard is basically a rule and it's made to protect the health and safety of the employee, okay? Why do we call it standard? Because we want it to be the norm. Okay. All right. And then, of course, standard, the next one, right, is a practice or procedure that is widely recognized or employed, exactly what we were just talking about. And then training, what are we talking about, right? Education, practical experience, classroom experience, okay, that's going to provide knowledge and experience to perform certain types of tasks or training, right? Okay, so let's talk about tasks or training for a second. I want you to remember this, is that OSHA mandates that every employee have two types of training, okay? Employees must be trained on the task that they're going to do. So if my task is that I weld, I have to be trained how to weld, okay? If my task is that I weld on stainless steel, I have to be trained to weld on stainless steel. Now, that's part of my task training. That's half of my training. The other part of my training is that I have to be hazard awareness trained for the task that I'm going to do and also where I'm going to do it. So now, so on the task side, I have to be taught how to weld and what materials I'm welding with, what equipment I'm welding with, and what I'm welding on. Okay, maybe even where I'm welding it. Okay, now as far as the for safety purposes now, hazard awareness, we also have to be trained on the hazards associated with the process of welding, and then where we're going to be welding. Are we going to be welding while we're on a scaffold, or we're going to be welding when we're in an above ground storage tank, or we're going to be welding while we're in a trench? Okay, so while we're underneath a dump truck. Okay, so regardless of what we're doing, we have to be trained two ways. Like I said, one is task trained, the other is hazard awareness trained. Okay, they're both going to include what we're doing and where we're doing it. Fair enough? Okay, good. Okay, so let's move on, right? I'm going to the white section, module 1 right there. So worker safety, what are we doing? We're looking to ensure both, right, compliance with the established standards or with the government standards and best practice standards, basically. Okay, and then there's a difference between compliance and best practices, right? We all know compliance is the law. Best practices may be like, let's say, maybe your corporate standards that you have. It may be, I'll give you a perfect example. Tying off is a requirement if we don't have guardrails or parapet walls or safety nets. Tying off is required. That's a requirement. That's a standard. However, 100% tie off, that's a best practice. Okay. Anybody else got any examples that you want to share? Compliance versus best practice? Yeah, absolutely, right. So tying off ladders. Somebody put tying off ladders. Yes, absolutely. So tying off ladders is definitely is another one as well. So hang on one second, folks. Give me 1 second, okay? Let me pause this for 1 second. All right, sorry, folks. Okay, so let me open this back up. Give me 1 second. Okay, so so there we go, the difference, right? So let's go to where it says best practice plans. I'm going to kind of skip over that. I mean, we all pretty much know best practice plans. Let's see. I think, hey folks, I'm sorry, I'm going to interrupt this really quickly. I see a couple of y'all keep on seeing this this caution sign, and we haven't been able to figure out what this caution sign means yet. Who's do me a favor, if you're watching this, can you let me know? I see a few of you have the caution sign. Let me know if you're on a computer, or let me know if you're on a phone, computer, phone, or tablet, please. I just want to make sure. I want to see if anybody's not able to send messages for any reason. Okay. Yeah, I think most of y'all are on computers. I'm just checking. Okay. Okay, good. Okay, yeah, I think mostly on computers. Okay, all right, no problem. I'm just checking because I know a couple of y'all are having some issues I think it's when you're on a smartphone, which is fine because I mean we can always make it up, or y'all can always call me. Okay, good. Okay, so let's move on, right? So competent person, right? Some safety programs require a competent person. Let me tell you when we're going to require a competent person most of the time. We're going to require a competent person in excavations for 5 feet or under. We talked about that a few weeks ago. For scaffolding, the design, the mantling and dismantling of scaffolds, and also daily inspections of scaffolds. Okay, for fall protection. All right, whoever's going to pick out the fall protection and protective systems, and how to design the protective systems and what PPE to use. We're also going to need one for confined space, and we're going to need one for rigging. Okay, at a minimum, we're going to need those 5. Okay, so let me go through them again. Right, trenching and excavation, fall protection, confined space, scaffolds, and can y'all remind me? I just missed one. I can't believe I lost that one. Did I just mention one the first time? Yeah, on rigging. Thank you very much on rigging. Okay, so at a minimum. Now, look, also, just so you know, a forklift operator has to be competent and qualified because they have to manipulate that load. Okay, and then crane operators and a bunch of other ones too. Okay, so at a minimum, it's all those. Okay, all right. So let's go ahead and move on. Okay, as we all know, most of us know, OSHA was established in 1970, right? It went into effect in 1971, and basically all the laws since 1971 that have been written, it took an act of Congress. It literally took an act of Congress called the OSH Act, OSH Act, which actually, or the William Steiger Act, that actually put the OSHA standards into effect in the office of OSHA. And then the office of OSHA. And then it takes an administrative law, or a CFR, Code of Federal Regulation, that that OSHA must do anytime they want to introduce a new standard, okay, or change a standard, okay. Okay, so let's move on. So we talked about accident investigation. Let's talk about it here, right? If there's a serious accident on a job, right, which 3 or more employees are going to be hospitalized, or one's killed, OSHA has to be notified. That's changed now. Ever since this book was written, now that's changed. Now, basically, what happens is that if there's a fatality, it must be reported to OSHA within 8 hours. Okay, so that's 8 hours. So let's say right now, what time is it right now? It's about 6:30, 6:45. Let's call it 6:30, right, for argument's sake. If an employee dies right now, and we just discovered that this employee died, we have 8 hours to report it to OSHA. So it must be reported to OSHA by 2 a.m. It's not business hours; it's hours from the time that we discovered it. Okay. Now, for a hospitalization, if an employee is admitted to the hospital, not emergency room, but they're actually admitted into the hospital, for any employee that's admitted into the hospital, it used to be 3 or more within 8 hours. That has changed since January 2015. Now the new standard is for any employee that's hospitalized, even one that is admitted to the hospital, not emergency room, we must report it to OSHA within 24 hours. We must also report the loss of an eye, and we must also report an amputation to any body part. Okay? So let me repeat it, folks. So a fatality, we must report within 8 hours. A amputation, loss of an eye, or a hospitalization as far as admitted into the hospital, those 3 are all going to be 24 hours. Okay? All right, so OSHA inspections. Let's talk about what happens with OSHA inspections. And they don't cover a whole lot in here on this part, but what we'll do is we're going to talk about a little bit about it right now, and then I'm going to be sending you guys out a handout for it, okay? But basically, OSHA has the right to inspect any workplace, okay? They have the right to inspect. You can tell them no, but if you tell them no, they're probably going to a district court, okay, or administrative court. They're going to get a court order, and they're going to come back with either marshals or local law enforcement or state law enforcement, and then they're going to come in with a warrant, okay? So you can deny them at first, but if you do, I can only imagine it's not going to be really good when that inspection actually goes down, okay? So OSHA, like I said, OSHA does have the right to inspect. They have the right to cite, and then they can penalize. Okay, so if an employer has even just one employee, they're considered an employer. So I do roofing work, right, or I do concrete work, or I do flooring work. If I have one employee, I'm an employer in the eyes of OSHA. Okay. Now my reporting, my OSHA 300 log reportable and information like that, that's going to be different. But as far as for me having to report a fatality, a hospitalization, if I even have just one employee, yes, I must. Okay. So, and then OSHA resources, right? You know, the resources, the biggest thing is going to be the OSHA.gov page. I've been showing you how to do more and more searches, and I'm in the next couple of weeks, we'll have some more pages that'll be going out, and then we'll go ahead and make sure everybody gets up to par on that. Okay. So different resources, where to find PowerPoints, how to do advanced searches. So you'll see that we'll carve out a little bit of time for that as well. Okay. And then of course, best practices. What are we talking about? Anything that goes above and beyond regular compliance, right? So that's one of the main principles of best practices. We're going to exceed. OSHA says that we can meet or we can exceed their standards. If we meet the OSHA standards, we're being compliant. If we exceed the OSHA standards, in those cases, we're being best practices. All employees are responsible to follow the company rules, right, and safety procedures. I'm on module 1, page 3. There's certain general rules that we have to do to promote safety. What do we have to do? Obviously, follow the rules, policies, procedures, right, for the job. You know, also we have to know the rules, policies, and procedures, right, and they have to be written and spoken. Okay, so OSHA says this basically. Let me ask you a question, and I think we talked about this already, but we have more people on the line now. How many employees do you have to be bound to OSHA? And I think I might have given you an answer already tonight, huh? Okay. So much for a good question, huh? I think we've talked about it a lot from the way it looks, and many of you knew it already. So if you have even one employee, we're bound to OSHA. What happens is at 10 employees, greater than 10 employees is what the standard says. Now we have to start doing written records. Now we have to start conveying our emergency action plan in writing. All right. And now we have to maintain an OSHA log. That's the number 10. But if we have even one employee, and we're going to be bound to OSHA, okay, with the exception of a family farm. But that would be the only exception. Or if you're under the direction of another government agency, like a military branch, or you're underneath the direction of the Coast Guard, or you're under the direction of MSHA, okay, the Mine Safety and Health Administration. Okay, so also in addition to following the rules, what else do we have to do? Never start a job until we've reviewed the appropriate procedures, right? What are we talking about? Our JSA, right? So especially if it's a job that's foreign to us, we should follow our task analysis and then our JSA as well. Never do a job that you've not been authorized to do. So if we haven't been trained and we haven't been authorized, we can't do certain work. Okay, we have to make sure that we have both the training and we've been authorized to do work in that area, folks. All right. Never start a job if it appears to be unsafe, right? You know, why take the unnecessary risk? So obviously, or we stop work, right, until the employer can determine that that we take all the safety precautions, put all the different controls into place, engineering controls, administrative controls, and PPE controls to make sure that we're as safe as possible while we go to work. Also, in addition to that, never put ourselves or our coworkers at risk, right? By engaging in any type of unsafe behaviors, staying focused on the job at all times, right? Thinking about, well, hey, what can happen, right? What can go wrong? And then also immediately reporting any type of job incidents, near misses, injuries, whatever you want to call it, right? Accidents, incidents, near misses, report equipment failure, right? Tool failure, reporting them to the employer or to the supervisor as immediately as possible. And then immediately reporting any hazards to our supervisor as well, right, to hopefully make sure that they can be corrected. And then also telling coworkers when to stop, right, working as well, if we see something going on that may be deemed unsafe. And then causes of accidents, right? What are we talking about? And you can see me skip right now from the left-hand side to the right-hand side. But items that can cause an accident easily often is using defective equipment. You know, that's very, very common, right? So using defective equipment can obviously put us at risk or harm. Also disabling safety devices, right? What are we talking about? Like bypassing guards, maybe maybe taking the power switch out of something, right, and just making a continuous current. Operating equipment at improper speeds. Uh, just because the equipment has multiple speeds doesn't mean that we always have to operate it on full speed ahead, right? Also, loading or placing the equipment or supplies improperly and or in a dangerous way. So a lot of times this will go back to our powered industrial trucks, right? Our cranes, our often pallet jacks, forklifts, okay? But also it could just be equipment period, right? Loading, unloading boxes, tools, whatever the case may be. Also working equipment improperly, working while impaired under drugs or alcohol, and then also horseplay. So all those we have to avoid in order to make sure that we remain safe in the workplace. All right. And then let's talk about a few things. We're going to talk about cost of an accident. Okay. So go to page 4. Horseplay, right? Not throwing water on somebody, obviously not giving them a Gatorade bath. It may startle the employee, especially if the employee is wearing hearing protection, if they're engaged in their job. So it may startle them. They may wind up putting their hand on the point of operation. Anybody who's not familiar with what the point of operation is, if you see that radial saw where it's cutting the wood, the point of operation is defined as where the tool meets the stock. The tool being the saw blade, the stock being the wood. Where the saw hits the wood, that's going to be where the point of operation is. Okay. Um, and then if you look at the right hand side, like I said, you got case history, fatal facts, right? Um, a case history of fatal facts. We've got the 10 basic rules of safety there. And then questions at the bottom. If you look in the middle, you'll see insured costs and uninsured costs or indirect costs. Anybody out there, let me know who's ever heard of this, of the iceberg effect, showing that the damages above the surface look far less and far cheaper than what the total cost is because there's so many hidden costs and hidden damages. Tell me if you've heard of the iceberg effect or not heard of it. Yeah, many of us, some of us heard of, many of us heard of it, right? And ultimately, this is what we're looking at: is that when somebody gets hurt, and let's say we're insured, these are the things that we see automatically, right? We're seeing the cost of medical bills, right? Premiums, compensation. Those are all the foreseeable expenses, right? What about the indirect expenses, right? Things that we see afterwards, like things like property damage, right? Equipment damage, okay? What about delays in production, right? Lost time. We're looking at how much time does a supervisor or supervisors having to dedicate to how much time are the supervisors having to dedicate to this to be able to address this hazard, right? And then any type of retraining or training of new employees, to hiring new employees, and then image and morale of the company as well, right? And then what they don't talk about in here is what about marketability of the company? What about the ability to bid on contracts, right? Yeah, an ounce of prevention is worth a pound of cure. You know what? Yeah, I'd look at it like that too, right? The iceberg, right? Just a little bit on top, and look how much the losses are on the bottom. I'd totally say all that. Okay. So there you go. There's where your biggest expenses are, right? Is towards the bottom stuff that we don't normally see. Okay. And then if you look at table 1 on page 6, you'll see where, first aid expenses, right? It'll talk about injuries, wages, loss of wages, production costs, right? Off the job accidents, intangibles, and then associated costs as well. So it's just giving us an example of all those different categories of losses that we can take a look at. I'm gonna let you look at that on your own time. Like I said, I'm more concerned about, like I said, the green, the blue, and then some of the facts in here. Okay, so that's why I'm gonna kind of push on us a little bit, and then let you do your reading during your time. And then there you go at the bottom section, the green section on module 1. Right, you got a couple of questions there. Why don't you do this? Take a couple minutes or so, And go ahead and just answer those 2 questions, and then look at page, because that way you can see what I'm talking about. Answer those 2 questions, and then go page 67, and just check your answers, folks. All right, and then we'll go back. Okay. Give it about another minute or so. Let me know when you're done with the 2 questions, and then you check them. I just want to make sure everybody's good with doing all the green questions on their own. All right, good. It looks like mostly all are done, so good. Okay. All right, and then like I said, we're not going to stop at the rest of the green sections. I just kind of wanted to give you a heads up. I might do one more just in case. Okay. So let's go ahead and go to PPE section 2, and then things that we're going to keep in mind, right? So what are we talking about? Obviously, we have one term there. What are we talking about? Safety data sheets, right? We're talking about our GHS, and we kind of talked about that when we did the little book. I'll kind of cover a little bit more tonight. And then what I'll do also is I'll send y'all, I got a little 3-minute video that I'll probably just YouTube it to y'all or something like that over the next couple of days so that y'all can see it as well. Okay, we're going to be loading more videos for you guys to see, some of ours and then some that we've got from the internet. Okay, so, so what 4 things can we do, right, with PPE, or should we be doing? Hey, regularly inspecting it, properly caring for it, using it properly when it's needed, right? And never altering or modifying it in any way. Okay. Also, the PPE, what are we looking at? What kind of PPE are we normally looking at? Hard hats, eye protection, safety harnesses, gloves, safety footwear, right? Hearing protection, respiratory protection. It could be things like welding gloves or aprons, y'all, chemical gloves or aprons, right? Anybody think of anybody got any, also maybe a vest, right? Like high visibility vest. Can anybody think of anything else? Okay, good. Okay. Um, and then, what are we talking about, right? Talking about making sure that we want to make sure it's all ANSI rated PPE, right? Are we in agreement with that? And then, okay, anytime when we have to wear a hard hat, really it's whenever they tell us to, right? But basically, anytime there's an overhead hazard where we may be potentially hurt, or we may also be exposed to electrical hazards, right? Or we're going to have to wear a hard hat. And then we got safety glasses, goggles, face shields. When do we wear them? Anytime when there's a risk to the eye or to the face. Yeah, FRC, you know what? Good call, right? FRC, right? For oil and gas, totally. Yeah, absolutely. Now, FRC is one of those, remember, that the employer is not required to pay for. Okay. Now, there, like, let's say rubber boots, like rubber boots with steel shank or steel toe. Yeah, an employer would have to pay for it. FRC is one of those where it's like our leather boots, we're required to pay for them ourselves unless the employer opts to pay for them. Okay. Just a rule of thumb, anytime we're required to leave the PPE at the job site or at the office, not the office, but at the job site or workplace, the employer's got to pay for it. Okay. Okay. So safety glasses, we know there's different types, right? We got safety glasses that may go, or goggles that may go over glasses. Some may not. So we've got both types. Making sure that they're ANSI Z87 rated. Okay. And then remember this, right? We have a shield and we have glasses. Remember, the glasses are made to protect the eye. The shield is made to protect the face. So we might be wearing of glasses without a shield because the significant risk is the eyes. But anytime we have a risk to the face where we have to wear a shield, we need to be wearing some type of glasses or goggles or spoggles underneath that. Okay, y'all okay with that? So glasses can be without a shield, right? But the shield cannot be without the glasses, right? Okay, cool. All right, great. Okay, and then we may have things like for leg protection also, right? We may have certain types of shin guards in place. Okay, depending what type of if we need any type of guards or anything like that, we may be using as well. And then we get into gloves. And if you look at the next page on page 10, you'll see that they have different types of glove hazards, right? We have gloves like impact gloves, also chemical gloves, dust, right? Light or radiation hazards as well. And then it goes on to give us all the information that we need about gloves in there. Okay, so those are different hazards that we have, and then what we'd be protecting from. Okay, and then of course, if we have any types of issues like rubber boots, and this is one thing you'll see warning that says always tape your pants into rubber boot tops, right, when working in concrete, right, or with chemicals. Be cautious of what they say there. That doesn't mean that, hey, tuck them in and tape them. All right. If anything, you should have them tucked out and then tape them around the boot. Okay. So it says, and that's why I'm not crazy about the way that says it. I'm not going to have people tuck Tyvek into the boot. I'm going to have people keep the Tyvek to the bottom and then tape the Tyvek around the rubber boot. Does that make sense? Okay, good. Okay, great. All right, if anybody needs any pictures of that, let me know. I'll probably have to walk in the back, throw some Tyvek on tonight or tomorrow, and take some pictures up for you, okay? Or I'll find some on the internet. And then, of course, we always want to protect our skin from any types of burn, sun, arc welding, chemical exposure as well, right? We also want to make sure that we have adequate foot protection as well. What are we looking at? We're looking at having a slip-resistant shoe. We're looking at having steel toe, right? Leather or chemical rubber gloves, depending on what the associated hazard is, right? And then our hearing protection, right? As far as what are we talking about when we're talking about hearing protection? We're talking about often one or two types, which is either earplugs, or we're talking about either earplugs, or we're talking about earmuffs, which are on page 10 and 12. So let me pull up a picture real quick. Let me show you a few things here. All right, folks, some of you may have seen this already, so let me show it to you for anybody who's not familiar with it. Whenever we wear these, right, as far as earplugs and stuff, every pair of earplugs will have something like this. Let me see if this picture, okay, here you go. The picture's clear right here. This high 32 NNR and RR. So let me show you what I'm talking about, okay? Here you go again. These are Howard lights, and you see it right there, NRR, okay, noise reduction reading. What that means, folks, is that if under the ideal conditions, okay, let's see, there you go right there, NRR 33. Under ideal conditions, if this hearing protection is inserted adequately, okay, and it's being used in ideal conditions, it should reduce the decibel level by 33 decibels. So if we're walking into a work environment that's basically 100%, right, 100 decibels, basically means that we should be getting somewhere around a 67 decibel hearing rate, noise rate, after the plugs are properly inserted. Okay, that's what that means. So if anybody's never seen it, that's what that NRR rate means. I think we talked about that a few weeks ago. Like I told y'all, we're gonna start seeing a lot of repetitive stuff, which is cool because it's just letting me cruise over it. Okay, all right. So there you go. There's an NRR for you. And then if you look at the maximum noise exposure levels, let me ask you a question, folks. Who's under the belief or the understanding that hearing protection starts at 90 decibels? I mean, at 85 decibels. Tell me if you're under the impression or under the belief that hearing protection, you have to put your hearing protection in at 85 decibels or 90 decibels. Go ahead and give me an answer on it. Yeah, okay, so this is what happens, right? is that the NRR base, I'm sorry. The what happens is that the OSHA, the action level is 85 decibels. Okay, and that's for the action level. When we have to actually put them in, will be at 90 decibels. Okay. However, what happens is most of our corporate safety plans and our client safety plans require us to put them in 85. That's when they tell us to put them in. So therefore, we follow in best practice. Okay. But let me show you OSHA standard, and then we'll do versus best practice. Okay. 1910, it's 1910.995. Let me find it under 1926 really quickly. I don't remember what number it's under. D52. So let's see. So what'll happen is that 85 decibels, 90 decibels. Let me bring it to 19. It's going to be in 1926. Even though we're in construction, the majority of the materials here at 1910.95. Okay, you're going to find that they have a lot more information here on this website than they do on the what do you call it? Just give me 1 second. On the construction standard. Okay. All right. So what will happen is that OSHA actually requires that at 85 decibels, the employer, it's called the employer action level. Here you go, right here. Okay, there you go. For purposes of this paragraph, right, 8-hour time weighted average, meaning that if an employee is exposed to an 8-hour workday, not 8 hours straight, I'm not talking about 8 a.m. to 4 p.m. I'm talking about for 480 minutes in a day, okay, to a dose of 85 decibels, okay, that's the action level. What happens at that point is that the employer now has to implement a monitoring program, like as far as audiometric testing. They also have to have a hearing conservation program, and in addition to that, they also have to provide PPE and training. Okay, so 85 is the action level. Okay, that's gonna be the action level. Okay, right there, and then it's gonna be put in at 90 decibels. Okay, which we just saw at 90 decibels for 8 or greater. That's when it's going to go into effect. Okay, and that's the table you see in your book. If you look at the bottom of page 12, that's why it says that 90 decibels for 8 hours. That's really where fall protection is by law. But we're going to go at 85, which is best practice, because what happens once our companies adopt it, the recommended now becomes our permissible limit, right? If anybody sees PEL, I just want you to know that PEL stands for permissible exposure limit. That's what we can be exposed to in that day's dose. Okay, and then REL, if you ever see it, is recommended exposure limit. One is law, one is best practice. You with me on that? Good. Okay, good. Okay, so let's talk a little bit about respirators, right? I know we talked about this already, so we're going to come back to it again. If you look at respirators, this is what we have going on. As the bottom left on page 13, we're talking about an air purifying respirator, right? It's cartridges on it, if you notice. And then on the right-hand side, you'll notice it's a pure air purifying respirator. I'm going to show you. Let me show you a better picture of a pure air respirator. A powered air purifying respirator. Okay, so let's see. Okay, here you go, folks. All right, these are the 5 types of air purifying respirators. Okay, we have a dust mask, a half face mask, uh, um, uh, a full face air purifying respirator, and then we have both of these: a loose fitting hood, okay, or a loose fitting mask, right? With which is a powered air purifying respirator, which is what you see in the top of picture 13. and then you also have a hood. So you have a mask, and it might be a half face mask, a full face mask, or and then you have a hood. Those are the 5 types of respirators, okay? As far as air purifying. And then these are air supplied. So air supplied meaning that now it's no longer purifying air. Now it's actually feeding us breathable air, right? Now we're on cylinders, or we're on some type of compressed breathable air generator, or breathable air pack that's going to be giving us air, okay? So now you see the difference of the two. So this I want you to know, not for test purposes, but I want you to know this for you. I want you to, air purifying respirator, I want to give you some gases that you can absolutely not use a air purifying respirator for, because we will die, okay? We must use forced air with all the ones I'm about to give you. Y'all ready? Okay. Nitrogen. I'll type them in too, okay, y'all? I'm going to type them at a minimum, these, okay? At a minimum. Nitrogen. Oxygen deficiency. Carbon monoxide and carbon dioxide. H2S and methane. If you use air purifying respirators with any of those, we will die. Okay. And then you get into things like benzene, toluene, hexene, all these other ene families, and any of those, it depends on what the toxicity level is. We may be able to wear a half face or a full face if it's a very small dosage, but normally we're probably going to go into some type of forced area also. Do you need me to repeat those, or you got them? Okay, good deal. Okay, great. Any of those that I gave you, all those are forced air, okay? They have to be forced air. Cannot use air purifying, okay? Air purifying is more for particulate matter. And then, like I said, some toxins, some volatile organic toxins on lower ends, okay? Lower dosages. Okay. So now let's talk about a half-face respirator and a full-face respirator. Let's talk about, we're sticking with air purifying right now, okay? We're sticking with these, okay? Let me ask you a question. Anybody in here wore one of these before? A half face or a full face? Okay, good. Okay, so those of you who've worn it, and let me show those of you. Okay, let me show those of you. What'll happen is this, right? I'm about to show you a key and a way. Okay. Okay, and I think I showed y'all a couple of these things last week, so so I'm gonna probably advance through it pretty fairly quickly. Okay, okay. So let me explain what's going on here. Okay, let's use. Okay, let's go here. Okay, so what you have here. Let me see. Trying to see if I can get us a little bit better picture than what I saw. Okay, let's go with this one right here. Okay, right here, if you look, folks, what'll happen is, you see this right here? This is called the key, okay? And the other one will be, it's called the key and a way, okay? So basically, the key will be on one side, and the way will be on the other. And then the way will be like this. You see right there now? You see how that one's got notches in it? Okay, what'll happen is that it's got to be the right brand respirator for the right brand cartridge, okay? So all these organizations work together to make sure that the key and the ways are not the same, because what we can't do is have this kind of key, right? Let's say on MSA respirator, and then all of a sudden we're able to put a filter for a 3M on it. Okay, so the key and the ways won't match up unless they're the same manufacturer. Okay, now some of them are even like almost more like a screw type. They still won't fit. It's got to be the right respirator for the right cartridge. Okay, so here you go. Here's a better picture of the way right there. You see it right there? So there's a picture of your way. Okay, and then let me grab that picture while we're at it. Okay. So there you go, folks. There's a difference between your key and your way for anyone who wasn't familiar with that. Okay. All right. Okay. So what'll happen is not only that, but also I want you to understand this, right? Is that for respirators now, it's not only that. Let's see. But also they're color coded. So these respirators, and they're different matrices in here that you can look at. Just do respirator color codes, okay? And then what'll happen is it's actually going to send us, and it'll give us a map of what each color cartridge does. Okay, so as you look at it, you'll be able to see, and this is standardized as well. Each color cartridge will protect us from a different type of hazard. Okay, some of them will do each other's job, but it's not a guarantee. It's not like you can just grab one and just put a respirator, what you call it, a filter on it. Okay, got it. And if you need it, just Google it. Okay, I'll tell you what, the easiest place to know it is when you buy. Is the easiest way to know it is when you buy that respirator, read the instructions that come with it. Okay, or when you get the cartridge, read the cartridge to make sure that it applies to the gas that you're actually purchasing. I mean that you're actually going to be exposed to. Okay, for the cartridge y'all are going to be purchasing. Okay, all right. So that's air purifying. Now, so let's move on, and then we're looking at supplied air on the next line, right? So we're looking at supplied air two different ways. So let's say we're doing SAR and we're doing SCBA. Okay. Okay, so now when we're talking about SCBA and SAR, this is what we're talking about. SCBA is going to be something like this, okay, right where we have the tank on our back because it's self-contained. We have the air with us, right? Any of these, it's self-contained, so it's SCBA, self-contained breathing apparatus. And then what will happen is with if you look here in this picture, this employee does not have a backpack on him. He's on an SAR, supplied air respirator, which means that they're bringing air from back here, bringing in a line. They're bringing it to the front of his hood mask, okay? And they're tying in, so he's getting fresh air. Anytime we're on fresh air like this, or SAR, or if we're on SCBA, if you're on SCBA like this, you do not need an emergency pack like it's in the book. In the book is just they call it a little 5-minute pack or emergency pack, right? Which is the same picture here. It's not required. It's only recommended. But when you're on fresh air, you have to. And the reason being is because if your line is cut, you have to have enough time to get out. The belief is with an SCBA, with the warning systems on SCBA, we should be able to become aware of when we have to evacuate the area, and we still should have enough air to get out. Whereas it's always a best practice to have it, but whereas it's with the, like I'm saying, when it's with the with the air supplied air respirator like this with no tank on your back, and then you have that you must have a 5-minute pack. Okay, and then also let me see if I can pull up an escape pack for you also. Let's see. Anybody ever seen these before? Something like this? You put the plastic bag over your head. That's an SCBA also. They'll do them a lot like in refineries. They'll have them like in areas where it's H2S heavy. And basically you just put the bag over your face and it's just enough to get you out, okay? It's not so you can do any process or anything. It's strictly so you can go ahead and just evacuate and get out of the area, okay? All right. So let's move on. So now we talked about SCBA and SAR, right? We talked about air purifying. And then if you look, there's a little checklist there, right? Before we're in the respirator, this is what we got to determine. Okay, the type of contaminant, right, for which we're going to have a respirator on for, right? Why do we have a respirator on? Okay. In addition to that, the concentration level that contaminant is going to be. and then whether the respirator can be properly fitted on the person's face. Okay. And then what happens is, in order to know that if it's properly fitted on the person's face, what happens, we have to have a pulmonary test done. We have to be able to blow a certain amount. And that's because we want to make sure that we don't have any restrictions by putting a an employee is not restricted, their head is not restricted by putting that respirator on. And then also they have to be fit tested as well. Okay. You got to be fit tested annually, folks. Okay. I think your medical evaluation, I'll look it up, but I'm almost certain it's 3 years. Every 3 years, you have to have a medical evaluation. And then you have to be fit tested every year or after any type of life-changing event. If you've been in a significant car wreck or any type of bodily injury where your face has been damaged, and then you have to be fit tested. Okay. If you've gained a significant amount of weight or you've had a significant amount of weight loss, and then you also have to be fit tested as well. Okay, we're good. We're gonna hit respirators again, but we're okay on it for right now, y'all. You got enough on it? Okay, good. Okay, if anybody wants me to come back, I'll come back. Okay, and then limitations that apply to half mask respirator. We just kind of talked about a lot of them. Let me tell you things like we said: oxygen deficiency, half face or full face. Let me tell you in situations where you can use air purifying, but let me give you a perfect example of when you cannot use a half face. If you're doing lead remediation, perfect example. If you're remediating lead, you must wear a full face respirator. And the risk is because what we don't want is the lead to go between the eyelids and eyeballs and it get into the person's bloodstream. Okay, so that's why, and really asbestos too, we should be using, because of damage to the eyes. In both of those cases, we should be using full face respirators. Okay. Okay. So let's go ahead and move on. Oh, I'm sorry. One last thing. If you look on page 15 to the right, what are we going to do? We're going to follow certain guidelines, right? We're going to always inspect the condition of our respirator before we use it. Okay. We're not going to wear the respirator, if the face piece, right, is distorted, if it's cracked, if it's worn, if there's any issue with it. We're not going to wear respirators, right, if any parts are missing. And look, let me tell you, folks, let me go back to a mask, right? A lot of times these things will have a washer on them or some type of O-ring or bladder or something, okay? We cannot, if let's see right here, right? You have a ring on it right here, like an O-ring on it right here, or a flat washer. If that washer goes out, and this is an MSA mask right here, it's hard to see, but it's an MSA mask. If it goes out, we have to replace it with an MSA flat washer. Okay, you can't grab one from a Draeger. You can't grab one from a 3M. Okay, you can't go to Ace Hardware or Home Depot and pick up a rubber washer. It's got to be the right rated washer for the right type of equipment. All right, only person you get them from is a manufacturer. I think last I heard, Scott respirators. Let's see, Scott is running about I think about $8 for the washer plus shipping. So you're probably looking at $15 for the little bitty washer. Okay, anybody know? Anybody care to do me a favor? Half face respirator, right? I'm talking about something like this, something this simple right here, folks. All right, this half face respirator, actually that one does not have the cartridge on it. Let me get one with the front cartridge case on it. Trying to get one that doesn't look so Darth Vaderish. Let's use this one. Let's just use this one for an example, right? A respirator like this. Anybody care to guess what a respirator like that costs? Ballpark? Throw me a number up, better yet. No, not that expensive. I'm not going to give you a number out yet. All right, we got numbers all over the place, but that's good. You see, that's how crazy it is, right? All right, yeah, that respirator, and look, let me just do this. Let me go to shopping now. That respirator is going to be about, probably, it's going to be about $350 from last I know. Okay, so there you go. Look, $349. All right, so about ballpark 300. But look where your numbers were. I had numbers as low as $80, $50. I had one as low as $50. I had prices over $1,000. Okay, so the thing is that this is the thing. It's plastic. You think that plastic costs $350? We're paying for the liability, y'all. Okay, it's just like yo-yos and fall protection. We're paying, especially the yo-yo. We're paying for the liability is what we're paying for. Okay. So now you just have a ballpark idea. Like I said, I mean, I think a good average I would say is $250 to $500 for a decent full face respirator. Okay. All right, so let's go ahead and move on. I'm gonna we'll get a break in about 10 minutes, y'all. Okay. Let me see. Let me see how long this section. Let's push through this one. I think we'll get this next section in. Um, so then what are we looking at, right? We're looking at section 3. We're looking at hazards associated with walking and working surfaces. So what are we looking at? We're avoiding walking and working surface accidents, right? Like what are we talking about? Common examples of hazards might be where employees may be experienced to hazards, either openings or hazards on the floor, walls, working platforms, right? Stairways, ramps, stairs. We may, if we have ladders and scaffolding and roofs, is usually where we're talking about where the injuries may happen if we don't access the that all those safely enough. And also in addition to that is if there's any damage or trip hazards on them as well, right? And then and then things that we got to remember as well is that the following are some types of openings, right, that we have to be aware of: stair openings, chutes, trapdoors, manholes, hatches, where we may be exposed to a hazard as well, right? And to avoid slipping, tripping, or falling, what are we going to do? We're going to check for ice or snow, right? If the ice can't be removed, we wear footwear that's got skid resistant cleats on it. We also want to make sure that the floor is clean and dry. You know, if there's any type of wet process, we want to use in the work areas, we have to make sure that that it's properly drained and it's graded, or we have mats on it. Okay. We also have to keep the floor clear of tools, equipment, and materials, right? That could, we want to make sure that we control any type of littering or tripping hazards. And then ultimately, we want to avoid, uh, openings in floors, right? As much as possible, and guard them, or go ahead and cover them if possible as well. All right. And then ramps and walkways, you know, things we want to do to avoid slip, tripping, and falling. We want to check and make sure the surfaces we're using, you know, before using it, right? If we find that the ramp is any type of slippery ice or anything, we have to get it off of there. If not, we also may wind up using skid resistant cleats, you know, or we may wind up using either skid resistant cleats as footwear, or we may have skid resistant ramps or ramps with cleats in it. So anybody who's not familiar with ramps with cleats, let me show you what I'm talking about. Okay. All right. Yeah. Somebody said they were way off on the price of a respirator. So I would definitely say don't play the prices right this week, man. You know, I'd brush up on your pricing first. Okay. So let's see. Let's see. We can have cleats on for footwear, or we can have items like this that we often see, right? This is what I'm talking about. When I'm talking about cleats on a ramp, that's what I'm talking about, folks. Okay. How many times you see that, like going into a trailer, maybe, right? Where there's a lot of rain, where there's significant hazards. We'll end up seeing that we'll end up building a lot of cleats like that. Okay. Okay, great. Okay, good. Okay, so let's see, and now I'm moving on to page 18. You know, things we want to make sure, right? Make sure that the ramps are clear of tools, equipment, materials, and debris. Make sure that any tools or equipment that we're using or carrying, you know, turned off and secured, right? Help prevent any type of injury or falls. You know, and then items that we want to talk about, right? What are we talking about? Like stairwells. You know, stairs, we want to make sure that, you know, anytime we're using stairs, we want to make sure that they're uniform, they're in accordance with the OSHA standards. I'm going to show you where the OSHA standards are on them. In addition to that, anytime that the stairs consist of 4 or more risers, right? So what I'm going to talk about, I'm talking about the steps, right? So let me take you to risers. 4 or more risers or steps. So here's a riser, right? Here's 1, 2, 3, 4. Anytime it's 4 or more, what happens is we have to have a guardrail now. We have to have guardrails in place, okay? Or guardrail around it. So 30 inches or 4 or more risers. I'm gonna tell you what, most trailers make sure that we have them well before that. Okay. As y'all notice, I mean, if we're going more than 2 steps, if we're usually going 3 or more because of best practices, they're usually putting it in place. Okay, but at a minimum 4. So there you go. There's a perfect example. All right, we good on that. Now, something I want to show you is this, right? Is that the height of it's called your rise and your run, or your rise and your tread, right? Your rise and your run, or your rise and tread. The rise has to be uniform on each one like this. all right, within a quarter of an inch, okay? So here, if it's a 7-inch rise, here it can't be less than 6 3/4, or more than 7 1/4, right? So 7, 7, 7, 7, 7, and then the depth of the step is normally about 10 inches, anywhere from 9.5 to 11.5 inches, okay? So the depth of the step, okay, the tread on the run, all right? So there you go, folks, okay? All right, and then roofs, right, on the right hand side, things we want to watch out for, right? Walking and working surfaces on the roofs. What are we going to do, right, to follow guidelines to make sure that we stay safe? We wear boots or footwear with rubber, right, or creep soles that are in good condition. Also tell people that also watch out for your for boots. If you let me ask you a question: who out there wears pull-up boots, and who out there is wearing lace-up boots or lace-up shoes? Yeah, slip on. Yeah, a lot of us do, right? It's easy. It goes fast. Um, a lot of times, creeps. I'm trying to show you what the creeps look like. It'll wind up being just soles that can help us attach better to the ground. Okay, to the roofing. Okay. Um, and that's the thing. Most of us wear pull-up boots. It's definitely, if you have employees doing roofing work, in my opinion, I'm going to tell you, I want them in lace-ups. Okay, it gives them ankle support, right? It's not as easy to slip out the boot, and it's just significantly less risk. Okay, so just so you know, from my position. Also, always wear fall protection devices, right? Even on shallow pitch roofs. Now, OSHA's got some deviations to that. They say anything low slope, we don't have to. And believe it or not, low slope is 412 pitch. Let me show you what a 412 pitch looks like for anybody who doesn't know. It's actually pretty steep. There you go. There's a 412 slope right there. Basically meaning for every 12 feet you go in, we come 4 feet up. 12 feet in, 4 feet up. Okay. So it's still it's still a little, for me, here you go. It's, for me, it's still a little bit too close for comfort. Okay. So 412 from this and down, we don't have to have fall protection. Okay. Because residential. But I'm not with it, y'all. I think it's a little too steep. Okay, so but just know, you know how it is. Like I said, 612 basically means for every 12 we come in, we're going 6 feet up. Okay, 12 feet in, we're going 4 feet up on the 412 or 612 slope. For anybody who's not familiar. Okay. Also, rain, frost, snow, right? All types of dangerous conditions. We want to make sure that those have been eliminated. If not, we're wearing skid-resistant shoes. But most shoes are skid-resistant, y'all. But I'm gonna tell you, I was just talking to somebody here. I got a pair of. Let me show you what they look like, right? And they're a few years old, but I hate to get rid of them because I've rarely ever worn them. But I'm gonna tell you why I've really never worn them. Anybody had Timberlands like this? Like this exact shoe right here. Anybody ever had them? Okay. I'll tell you what, I like Timberland, y'all, but I don't like this shoe. Let me tell you why. It's really narrow right here in the front. It really points in a lot, if you can kind of tell in the picture. All right, it gets kind of pointed in the inside. But more importantly, I don't like them because they're not that slip resistant. It's a slip resistant shoe because they all have to be slip resistant these days. But I got to be honest with you, I usually you wear Timberland boots, right? Um, I'm wearing Red Wings now, a lot of Irish setters, stuff like that. But your lace up boots like these for Red Wing, great shoe. Okay, great shoe. Okay, I mean they last a long time. I think they actually fell apart on me before I actually wore them out. But the last two sets I had. But I got to tell you, it's way more support. Okay, and then way better traction on them as well. Okay, so not all slip resistant shoes are the same. All right, so let's keep it going, right? So then on pitch roofs, oh, also brush or sweep, right, roof periodically or blow it off if possible. Let's see, on pitch roofs, install the necessary roof brackets, right? Roof brackets, you can see them on your right-hand side. Okay, the biggest thing is I want you to know about these roof brackets. When you put them in with nails, right, or you put them in with spikes, they usually come with spikes. You have to keep the spikes, okay? So let me go to, let's see. When you go to these roof brackets like you see on the right-hand side in figure 16, you got to go back. If they come with spikes, you got to go back with spikes. You got to order more spikes. You can't just go buy nails or screws and screw them in. And the reason being is you have to have the shear strength. And basically the shear strength means that it's not going to rip it out the ceiling or rip it out the wall, okay? So let's see, roof bracket. So this is what I'm talking about right here. Okay. So when you use them, okay, if it screws, it's going to tell you what size screw you need to use. Okay. And then when they bite in and you use the spikes, it's going to tell you to use the spikes, or the manufacturer will tell you what alternative you can, whether you're going to be using like 16 penny nails or bigger, thicker nails. So remember this, anytime you have a piece of equipment like this, the manufacturer will always instruct us on what we can and can't do with it. All right. We're in agreement with that, right? It's always the manufacturer, right? All right, good. Okay, good. Okay. And then in addition to that, right, if we do warning lines, we'll talk about warning lines a little bit later, because this is what happens with warning lines, okay? Is let me and I think I showed y'all this already. Let me show it to you again. About the next 2-3 minutes, we're going to pull a break too. I'm just pulling off these last few lines right now that we're doing. Okay, so here we go. All right, folks, I want you to remember this, right? Okay, who's familiar with a control access zone like this? Okay, or staked off on a rooftop? Most of you familiar with it? Okay, good. Okay, this is what I want you to know, okay? Is first of all, if the level is higher than 30 feet from where the control work access zone is to where the next lower fall is, if it's greater than 30 feet, we can't use it. We have to go back to personal fall arrest, okay? If the fall is greater than 30 feet, you can't use it. So let's say you got a 3-story hotel building and each story is 12 feet, 36 feet, you're out of it. You can't do it anymore, okay? Now, what happens is when you put up a control work access zone, anybody who are not roofers have to stay at least 15 feet away from the edge. Okay, so basically, let's say, let me take this right quick. Here we go. Let me see. Okay, so if I have non-roofers, and this is my line for 15 feet, okay, if that's my line for 15 feet, I gotta stay further away. Okay, so what happens is for non-roofers will have to stay this far away, and they'll probably be able to only work on this area, 15 feet away from the perimeter without fall protection on. Roofers can stay within 6 feet of the edge. So only the roofers can work within this area. Okay. So non-roofers stay 15 feet away from the leading edge. Okay. Roofers can stay 6 feet away from the leading edge unless they're operating a mechanical truck, like let's say a concrete buggy or anything else that's motorized. And then if they're traveling towards the leading edge like this, now you have to stay 10 feet away. Okay. So non-roofers 15 feet all the way around the whole edge, right? You see how little space they have? 6 feet on foot or mechanical equipment running parallel for roofers, running parallel to the 6-foot line. If they're running towards mechanical equipment, towards the leading edge like this, now you're talking about 10 feet away for roofers only. Y'all good with that? Okay, good. I'll drop a little bit better map too. Okay, I got a 510 going on, started today, so I'll drop a map because I want to give them a better shot of it. I'll show it to y'all next week or Thursday. And then last three, and let's take a break. Right, removing any unused tools, cords, or other equipment. Also, being alert of any other potentials, right, hazards, right, with live power lines, and then using common sense, right, taking chances we know can lead to injuries, illness, or fatalities, right. So let's do this, folks. Let's go ahead and break out for a few. Okay. Um, why don't we do this? I got 7:42 on my clock. Why don't we reconvene at 7:55, and we're going to push it through all the way till till between 8:50, no later than 9 o'clock, but closer to 8:50 or 8:55. All right. I'm gonna shut the screen down. I'm gonna leave it on y'all, and then I'll see y'all in the next 12, 13 minutes. Okay. Thank y'all. All right, folks, let's go ahead and kick it back off, all right? Can y'all check in? It looks like everybody's back on, huh? Good. Okay, good deal. Okay. Looks like most of y'all are checking in. All right, so let's go ahead and I'm going to pick up the pace just a little bit, all right? Y'all okay with me picking up the pace just a tad bit? Okay, good. Okay, good. All right, so let's roll, right? Okay, good deal, y'all. So let's roll, all right? All right, so let's just talk about really quick, all right? Heat stress. We're going to talk about heat stress, cramps, exhaustion, and stroke. You're going to see how many of these are so similar, okay? I mean, they're very similar, and then I'm going to tell you a couple things I want you to know, okay? So, so things, let's talk about it, right? So heat stress, right? What's the best things we can do to prevent heat stress? Hey, drink plenty of water, avoid alcohol and caffeine. Not only avoid it that day, but definitely not drinking on the job, right? But also try to limit it the night before as well. But, obviously, I mean, everybody wants to do what they want to do, right? During their own time, and they have the right to. So, but, going back to fit for duty, right, is what we're looking for, right? Rather than eating a recordable and getting somebody hurt, a lot of times we're doing fit for duty, stretch and flex, making sure that employees aren't coming in inebriated, right, or non, what's the word I'm looking for, or still under the influence, right, the next day. Also, when possible, can perform random strenuous work. Go ahead and perform the most strenuous work in the morning, right, early part of the day before the heat really starts kicking in. Wear light colored clothing, wear loose fitting clothing as well, right, where it doesn't create a hazard. Wear a hat, right, or a wide brim, or y'all seen those brims that they have for the hard hats now, right, or the neck shields as well, the neck curtains or whatever you want to call them. Also taking frequent and short breaks, and then rest in the shade whenever possible, right? Okay. I'm going to tell y'all in the next few days, I'm going to tell y'all an experience that I had with the BP oil spill about this. And I think that they just totally missed the mark. Everybody thought they were sitting on these trees, bridges, and everything else. They were in a heat stress management plan, and the whole public thought, oh, they're not picking up what they need to do. So they thought everybody was just sitting around because they wanted to sit around. Also, heat cramps. What are we looking at? So then we're looking at, all of those, right? And then why drink at least, and this is the thing, right? Drink 1 to 1.5 gallons of water a day. So here's my question to you: what's the minimum amount of water that NCCERs recommended we drink? Minimum amount that they recommend that we drink in a day. There you go. At a minimum, 1 gallon, right, or more, right? Okay, good. Just remember that. Okay, that's probably gonna be one of your questions in the back of the book. Might even make a good test question. Okay. Um, Okay, so let's talk about different ones, right? Heat cramps, which is the least severe of all of them. We're looking at muscle spasms, right? Cramping. We're looking at being maybe pale, sweaty skin, normal body temperature still, okay? Abnormal pain, and then it could be nausea as well. We can get into exhaustion. Now, what we're talking about now, the skin is the same, right? Still cool and pale. Now we start sweating more. We may start getting headaches, vomiting, nausea. Our pupils might become dilated. With heat exhaustion, our pupils might become dilated. So they're getting bigger, right? We start getting dizzy. We might possibly faint. All right. We get a fast and a weak pulse at the same time. And then we get slight elevation in body temperature, and that's during exhaustion. Okay, and then heat stroke, right, which is the worst one. What are we looking at? Now our skin is hot and dry, right? It's getting spotty. We're no longer sweating now, right? It's extremely high body temperature. Look at our pupils. They went the opposite way now, right? Now they went to excessively small. Mental confusion, headaches, vision impairment, convulsions, and possibly loss of consciousness. Okay, and look, folks, let me tell you, heat stroke, any type of stroke, medical stroke, whether it's heat due to medicine, right? Whether it's due to heat, whether it's due to illnesses. The Center for Disease Control basically says that roughly about 60% of the people survive a stroke. And of those 60% of people who survive a stroke, about 60% of those make a full recovery. So let's talk about that, right? So you got 100 people, 40 die, right? You got 60 left. Out of those 60 left, only 36 make a full recovery. And that's some of them from day one and some of them all the way through rehab. Okay. So it just depends, right? Okay. And then, and then let's talk about cold stress, right? We talked about heat stress. So let's talk about cold stress now. Okay. Um, so cold stress, what are we talking about? The two biggest risks are hypothermia and frostbite, right? And what are we looking at? Frostbite, what is it? It's a dangerous condition, right? That can have lifelong effects, right? It usually affects the hands, the fingers, the toes, the ears, the nose, all parts on the furthest extremities of the body is basically what they say, right? And what happens, and this is what I want you to know. These are symptoms of frostbite, right? The skin, it can get pale. It can get waxy white skin. Okay, I definitely want you to know it can get waxy white skin color, and it can get hard. Okay, and the skin can get numb. Okay, and then just basically think almost being frozen, right? Like a dead piece of meat being frozen is the best way I can explain it. And then remember the following, right? Never rub the affected area because it can damage the skin or the tissue. Because people trying to rub to warm up, they could be affecting the skin and not realize it. Also, after the affected area, has been warmed, it might become puffy or blister. The affected area might have burning feeling, numbness. And then when the normal feeling, movement, or skin color return, the affected area, they have to be dried and wrapped to keep it warm. Okay. And if there's a chance of the area that it might get cold again, and then what do you want to do, right? Don't warm the skin, right? So the biggest thing is that don't do anything artificial. Keep it as natural as possible. Just try to keep it as warm as possible. I'm going to tell you this, folks. Heat stress, frostbite, hypothermia, get them some medical attention. Okay, that's the best way I can explain it. And then hypothermia, what are we talking about, right? Hypothermia is when the body temperature drops, right? Even a few degrees, right? Anywhere from below 98.6. And then what are we looking at, right? It's potentially fatal condition. It commonly occurs outdoors in temperatures below 50 degrees. Okay. A lot of times the Coast Guard in the VP oil spill, they use this 50-50 rule. If the temperature was under 50 degrees and if the water was under 50 degrees, if it was under 50 and 50, you had to go into what was called an IFC. And if anybody, you'll know it, it's industrial flotation coverall. Let me pull it up for you. I'll pull it up while it's going. And what happens is this, right? Is if it's under 50 degrees of dropping, now hypothermia can happen, right? And especially if somebody lands in the water. So this is what I'm talking about right here. And this is to keep the body temperature. So when you get temperatures in above 50 degrees, this is what I'm talking about right here, right? IFC flotation devices. So let's see, IFC, PFD, or PDF. Listen to me. There you go. This is what I'm talking about right now. Now, that's called an IFC. Who's seen them now? Yeah, I figured most of you have, right? So good. Okay. Anytime you hear the term IFC, that's what it stands for. Okay. Okay. A lot of times people call them by their names too. They call it a Mustang, or what's the other brand? Sems or whatever it is. So a lot of times people call it Stennis or whatever it is. A lot of people call them by their brand name too, which is the manufacturer name. Okay. So don't be surprised if. Let me go back to that picture. As a matter of fact, let's see. Here we go. Right here. That's a Mustang suit right there. It says Mustang right there. Okay, so it just depends on what the suit is. But like I said, a lot of people will call them by their actual the name of the suit itself. Okay, so if you ever hear it, just so you know what it is. Okay. Okay. So moving on, going to section 5. Now, what are we talking about? We're talking about fire hazards, right? So we're talking about things that we already know about, like fuel sources, the fire triangle, flash points. Okay, flashpoint is the one I want to drill down on. Basically, flash point, what it is, it's the temperature at which a fuel gives off enough gas, right, or vapors to burn. So flash point, what happens is flash point, or the combustible, or as far as ignitability, right, to explosive or flammable, the only difference is going to be the flash point is at what temperature will it flash. So look at your trade terms. Let's go through them really quickly, right? There's your A, B, C, and D fire extinguishers. I want you to do me a favor. I want you to do something for me. I want you to read the A, B, C, and D fire extinguishers. I want you to read everything in green. Let's take the next 2-3 minutes, right? Read everything in green, and then do something for me. Flip over to page, let me see. Hang on one second. And then flip over to page 31. And there's your fire extinguisher types. Why don't we take the next 3 to 5 minutes? Y'all read those, and then let's blaze through them, okay? Y'all good with that? It's 8:08, so let's say 8:12. we jump back in and we keep rolling, okay? It shouldn't take y'all that long to rig it. All right, thanks. Let me know when you're good, folks, and we'll give it another minute, a couple minutes or so, okay? Okay, good. So let's go ahead and talk about them, right? It seems like most of y'all go ahead and got them. We're going to cover them anyway. So A, what are we talking about, right? Anything paper, cloth, wood, anything basically is going to leave an ash, right? A. B, what are we talking about? Flammable liquids, right? Gasoline, oil-based products, things like that. C, we're looking at fires for electrical current, right? Things to do with electricity. D, we're looking at combustible metals like magnesium, sodium, when they burn. And then what are we talking about? What are you normally using the fire extinguisher for? We're usually using it to interrupt the fire triangle, right? So we'll talk about it. And then also, we all know, anyway, who's fire extinguisher trained out there? Okay. Okay, so a couple of you are. Okay, good. Okay. So fire extinguisher trained, anybody who hasn't been fire extinguisher trained, what'll happen is when you pull the pin on it, it's called the pass method, right? So let's go to it. This is what we're talking about. So anybody who's not familiar with it, folks, this is what we're looking at, right? Is that you pull, it's pass. Pull the pin, you aim at the fire, you squeeze, and then you sweep. And when you sweep, you're sweeping at the base of the fire, okay? Because if you squeeze and you spray at the flames, it's not sufficient. You need to get to that base of the fire to put the source out, okay? So that's what we're looking for, okay? And then so that's your pass, okay? All right. So, and then, what we're looking at is, let's say, fire cabinet, right? The safety cabinet. What are we talking about? Safety storage cabinets. You'll see them in the next page. Safety can. We're talking about gas cans, basically. And you'll see them on the next page. And then sources of ignition, right? We know things that are going to actually produce the heat to complete the fire triangle. So look at the next page, and you'll see the fire triangle. You'll see the fire triangle on your upper right. corner, and then also you see the fire tetrahedron, right? Some people really practice the tetrahedron, which the tetrahedron, all it is we're taking the fire triangle and we're adding a chain reaction to it. There's got to be a chain reaction between the three. Okay, so let's talk about ABC fire extinguishers. ABC fire extinguishers. This is what'll happen: is A, it's taking out A is taking out the fuel. Okay, A is going to take out the fuel. So if the fuel is the wood, okay, or the plastic, it's basically wetting it in order to take the fuel out, right, and to minimize the heat. If it is a B or a C fire extinguisher, as you noticed on page 31, B and C are going to have more. They're going to be more like a carbon dioxide based with powder, a dry chem. Okay, it's carbon dioxide or dry chemical or a mixture of. And the reason being is what that's going to do is that's going to be used to help put out a little bit of the fuel, but more than anything else, is rob the oxygen in that fire. Okay, so actually, it's what it's doing is it's making that fire oxygen deficient, so it locks out the leg of oxygen out of that triangle. Okay, or that tetrahedron. All right, so combustible, right? Combustible building materials and debris. Examples are like lumber, scrap wood. Also, in addition to that, trash piles, bins, dumpsters, right? Bulk fuel, paints or solvents, right? Gas, propane, diesel, different things that can combust. Liquefied petroleum or LP gases, right? And then solvents like kerosene, paint thinners, acetones, items like that as well. Okay. On your right-hand side, you'll see the safety cabinets and you'll see the safety cans. And we're going to talk about those. So this is what I want you to know about the safety cabinets, right? And safety cans. And this one paragraph, a couple paragraphs I'm going to drill down on. The safety cabinets, they're important. Why? Because of proper storage of flammables and combustibles, right? The cabinets are common for a variety of job sites, right? They include construction, maintenance, renovation locations. Just like any other safety can, it's important that the cabinets be properly maintained, right? In good condition, installed properly in order to reduce the risk of any fire or explosion. Okay. In addition to that, some of the features include that they're vented so that they don't build up pressure. Okay, and with flame arresters. Okay, anybody did this last week as we talk. I'm going to pull up flame arresters so anybody who's not aware of it can see what they look like. And basically, what it is the flames only go one way. It won't allow to come back in. So let me show you what I'm looking at. It's a screen basically like this. Okay, and what it is that how many times you see that in a gas can? Anybody seen them in a gas can before, or seen them in a vent for a fire cabinet before? What it is, it's letting it vent out, but it's not letting enough oxygen come in. Okay, so it won't let the flame come in is what it's doing. Okay, it's called the flame arrestor, y'all. Okay, and then you have those, and then we talked about the flame arrestor last week on the hoses, right? And anybody who didn't see it, let me know. We're taking all the videos and moving them to YouTube now because we couldn't get more storage on what you call it on Go to Training. So they're trying to put us in a different package now. But for the time being, we took the videos off and we're going to upload them all to what you call it this week to YouTube for anybody who missed them. Okay, we're actually numbering them. We're changing the names on them. Now it's going to be by the book and by the page number. And then that way you kind of know what you missed. Okay. All right. Also, these cabinets, they have to be approved or they have to be in alignment with the NFPA, and they also have to meet the NEC standard as well. Okay. And then if you look at your gas cans on the right hand side, right, our gas cans, biggest thing you want to look at is that these gas cans that you see on your right hand side, they're also going to have to self vent. They're going to have self closing lids. Okay, or they're going to have to have a flame arrestor in them as well. Okay. The reason, like I was telling you last week, is that you can use a metal can. I mean, you should use a metal can. All right. In some places, you can still the plastic cans are acceptable, but most work sites won't allow them because you cannot ground to them. You can't bond between two containers, between a large container and a small container. And anybody who's not familiar with what I'm talking about, let me go back to this PowerPoint. Let me show you. This is what I'm talking about right here. Is that if you have a large container, let's say a fuel cell, right, a 55-gallon drum, whatever, a 500-gallon drum, the big drum will be grounded It doesn't have to be a pipe. It might just be a grounding rod in the ground, right? The big container will be grounded. And when we transport materials from this large container to the small container, we must bond the containers together. And when we're bonding these containers, that's why we're not supposed to use plastic gas cans in the workplace, because we cannot bond to a plastic container. Okay, and that's why. And that's in the flammable liquids standard, is where that is in the OSHA standards. Okay. All right. So one thing I want you to know about these gas cans, though, is I want you to know that these gas cans, they have to be UL listed. All right. Y'all got that? They got to be United Laboratories listed. Okay. That means that they have to have been approved and tested by United Laboratories. Okay. All right. So let's move on to the next page, and let's talk about, on the right hand side, right? The employer is responsible for laying out site, and keeping fire risk, right, at acceptable levels. But all workers have to be alert. So what do we have to do, right? We have to notify a supervisor if any fire exists, right? Escape routes are not clear or passable. We either need to take corrective action and or notify the supervisor. Any areas are not accessible for firefighting, right? We have to be able to have people come in with firefighting equipment in order to try to put out an incipient fire or full blown fire. Also, fuel storage and dispensing areas, right, are not set away from the rest of the site, because we can't have them in an exit route, and we can't have them where they're going to cause more issues if they're the ones that go up, right? So that's why we keep them in the remote areas by themselves, or isolated areas by themselves. People can't smoke anywhere around it, right? So now we're going to have that. It's going to be no smoking within 50 feet or 25 feet or 35 feet, depending. It's usually going to be about 35 feet, okay, where we're not going to be able to produce any spark or any heat. And also, if you have any type of fuel cell like this on the screen, you're also going to make sure that it's going to be noted on the fuel cell as well, that you can't smoke by it, okay? And what I'm talking about when I say a fuel cell, folks, I'm talking about something like this, right? I'm talking about a fuel cell like this, or I'm talking about a round tank. Let's see. Talking about one like this, okay? 500, 750, 1,000, depending on whichever one you're talking about, okay? All right. And then what else? Electrical systems that are not properly bonded and grounded, right? And like we said, anything on these fuel cells is going to be properly grounded, because some of them are going to either have battery or electric operated pumps. So that's why we still have to make sure that they're grounded, okay, and bonded. And then the best way to prevent a fire is what? Make sure that we have those three elements, right? Fuel, oxygen, and heat. And we try to knock out that fire triangle, the tetrahedron. We always want to work in well ventilated areas, right? Especially when we're using any type of flammable materials like shellac, lacquer, paint, strippers, right? Or we want to be able to ventilate and make sure that if our LEL's up there, it's going to have to be some type of intrinsically safe equipment or natural ventilation. Never smoke or light matches when working around flammable materials, right? We're keeping oily rags in approved containers, self-closing metal containers for oily rags. Also, store combustible materials only in approved containers, right? Who they're going to be approved by: NFPA, United Laboratories, right? NEC, National Electric Code, all of those. Also, making sure that all tarps, right, and covers are fire resistant. And then, also to make sure that we use any type of temporary heaters only when and where we absolutely have to. We're talking about like heaters like salamanders, space heaters, items like that, right? Especially no makeshift ones. Sometimes you'll see people. Y'all remember those old home heaters? I don't know if y'all remember this. Let me show you. I remember back in the day. Y'all remember these old gas heaters like this? I've seen guys hook them up with propane and come light them in the workplace. Okay, I haven't seen it in years now, but it's just items we need to watch out for. Okay. Let me see. Yeah, you don't even really see it much anymore. So items like that. Excuse me. So let's see. And then having no more than 1 day supply inside of a building, right? And keeping the material. This is what I'm talking about. And you see a UL listed safety can. Okay, keeping the amount of fuel on site as low as possible. That's why if we get, even though we got a 500-gallon cell, we may not want to use all of it. Dependent, especially if we start doing reduction of forces and stuff, we might be wanting to go down that amount. But we're all in agreement that it's got to be in the UL listed safety can, right? Anybody who doesn't know what it looks like, let me show you. It's just going to be the seal on it. Okay, let me show you what I'm talking about. There you go. You're going to see that seal on that gas can. Okay, that's the UL listed can. You'll probably see a bunch of them. Items like a lot of these. Okay, compliance with NAPA, OSHA, right, and then approvals and the different ones that it's approved by. Okay, and then looking around before setting any ignition source, right, using a grinder or welder, do air testing, right, whenever we do hot work testing, know how to report a fire. How do you report a fire? Might be pulling a fire station, right? Might be calling 911. Might be an air horn, a bullhorn. Depends on what's going on. And then always report potential fires as well. Okay. Just give me 1 second, y'all. Okay. And then selecting and using fire extinguishers, right? Y'all went through the whole list, A, B, C, and D. Everybody comfortable with the type of fire extinguisher? All right, study up on those, y'all. Okay. Those are really important to know, not just for the test, but they're really important to know for every day too. Okay. And then the only thing I'm going to talk about in the next page, you see the instructions there, right? Different ones, different fire extinguishers. And the biggest thing I want to show you there is the components of your fire extinguisher. Okay. Oh, you know what? I'm sorry. Go back one page, y'all. Sorry about that. Go back to page 27, and you'll look and you'll see that you have 4 different classes fire extinguisher, right? But look, and we talked about this. Whoever was on early on in the first book, you have A, B, C, and D. But look at it. They're standardized by letter. They're standardized by shape: triangle, square, circle, and star. And they're also standardized by color. Okay, so there's 3 different standardizations there with those fire extinguishers. Okay. Then the next page, page 28, you got your tamper seal at the top, right, or your pin. You got safety pin with your tamper seal. You got your activation lever. Remember, on a fire extinguisher, it's not the bottom is the handle, the top is the lever. Because if the bottom was the lever, as soon as you pick it up, its own weight might discharge it. Okay, that's why it's always going to be the top lever that's going to come down, and never the bottom lever that's going to go up. Okay. And then your inspection tag, right? Your annual inspection tag, monthly inspections on it, noted on it. You're going to have them hydrostatically tested each year, or tested each year, pressurized tested every year. Also, pressure gauge indicator, make sure it's in good shape. The sight glass is in good shape, and the regulators shows that it's got adequate pressure. Also, the proper label, and then the classification symbols we just talked about, and the cylinder itself. Okay, so there's all your components of a fire extinguisher. Okay. All right, so now I'm skipping through y'all. I'm going to page 30. And page 30, I want you to do me a favor for the next minute. Read the 7 sections of the 7 steps on page 30. Okay, and then we're going to keep on going. Okay, so things we got to do, right? Step 1, sound the alarm, right? I'll call a fire department. Here's the thing, y'all. It depends on what it might be. For NCCER purposes, let's go with always sounding the alarm first. because your first step may be to grab that fire extinguisher to see if you can put out an incipient fire first. Okay. So, identify, right, the safety evacuation path, right, how we're going to get out of there, right? Don't allow the fire, the heat of smoke to trap us in there, to entrap us. Select the appropriate type of fire extinguisher. Most of your work sites probably have an ABC fire extinguisher. That's probably what y'all using, except in a refinery, you're probably using a BC. Is that a fair assessment? If you don't know, let me know you don't know. Okay, so we got mixed bag, right? We've got all the answers coming up. Yeah, so this is the thing. In most commercial applications like offices, right, on trucks, UTVs, stuff like that, we usually have ABC, y'all. It's usually a combination fire extinguisher. Now, in a refinery or around electrical rooms, right, switch gear, stuff like that, y'all. Anybody who doesn't know what a switch gear is in MCC, let me show you real quick. I'll show you okay, here we go. When I'm talking about switch gears and stuff like this, now who's familiar with a switch gear? I know I got a couple of electricians on the line, right? So different switch gears, buckets, depending on what type of equipment it is, right? And then also you might have an MCC. It's usually the room. It's a master control center, and it's usually a trailer or a room where all this equipment is. So the switch gear is all this. The MCC is the room that all this will be in. Okay. So if you ever hear that, let's see, let me do refinery MCC. Let me see if it comes up. It may be there you go. A lot of times you'll see it'll be in a room, enclosed room like that, or a trailer. Okay. And let me see if I can do a unit or modular. These rooms, right? You see these rooms like this in a refinery, folks. That's what I'm talking about, like a modular. That'll wind up being where they'll have the MCC a lot of times located. Okay. It's like a blast-proof modular. There you go, right there, folks. Okay, y'all seen those before in refineries a lot of times. That's what winds up being in those things a lot of times, y'all. Yeah, a lot of times what'll wind up being in it is different types of switches, buckets, and items like that. Different electrical components. Okay, master control center is what it stands for. Okay, all right. So go through. Let's finish going through the steps. Right. Select the proper type of fire extinguisher. Discharge it right using the pass method. We're going to back away from the extinguishing flames as we move backwards. Or actually be cautious of moving backwards as well. Right, walking backwards. Evacuate immediately, and then also evacuate immediately if the fire gets too big. Remember. Bottom line, remember what the reason for a fire extinguisher is. It's got two primary reasons, y'all. The first primary reason it's got is basically to get us out safely. I mean, that's the number one reason we have a fire extinguisher. And usually why we have it towards the exits is to be able to get us out safely where we are. Okay. But also on top of that is to try to hopefully help put out an incipient fire. Okay. So it's both of those, and those are both the main reasons why we would have that. Okay. All right. So let's go ahead and move on. And like I said, what's step one, y'all? As far as NCCER, what's step one? I know we're probably grabbing the fire extinguisher first, and I know I am, but what's step one? Because I promise you're going to see that again. Yep. Sound the alarm, right? Notify, right? Okay. Okay. Emergency action plans, right? 5.2.2. What are we looking at, right? It consists of the following items. We have to have conditions in which an evacuation would be necessary, right? Basically, we have to be notified, why we would have to evacuate, period, right? Also, what's a clear chain of command? Who's in charge, right? I want you to remember this. If you ever see in any NCCER reference, chain of command, what are we talking about? We're talking about the person who's authorized, right, to order an evacuation, or the person who's authorized to make decisions when we talk about a chain of command, okay? We're talking about the chain of authority, okay? Also, evacuation procedures, emergency action routes, designated meeting areas outside, right? Our muster stations, right? As we'll call them as well. So anybody who's not familiar with the term muster station, you might want to get used to it, especially for refineries and manufacturers. So let me go to it. The people that work on in schools, are y'all using muster stations or assembly point? What word are y'all using? Are y'all just calling it that tree over there? Okay, so this is what I'm talking about, right? Anybody who's not familiar, these are the signs you're starting to see now. Okay, and basically muster station just means everybody's mustering up in that safe area. Okay, so you'll see it a lot of times when you caught that, huh, Isaac? All right, y'all. Yeah. All right. So the corny jokes are coming out, right? So we got to start winding this puppy up, right? Okay. um, and then case history, right? Don't get burned, right? 1 gallon of gasoline, is the same as a force as 14 sticks of dynamite, so some crazy numbers, right? Also, I want you to remember this: as the gasoline or oil, excuse me, burning oil will expand 1,700 times over water. So it means that if you throw a gallon of water, it's going to expand 1,700 times over the top surface of that water. Okay, that's why grease fires are so dangerous, right? And then things that we have to have, right? We have to have that emergency evacuation plan. How many times you see in a hotel, you see that floor plan? Okay. Let me tell you, that's for everybody. Okay. That's not just for the person in the room, but what about when you got a housekeeper in the room? So NFPA protects us there as a guest, right? When we're in the room, but it will protect the maintenance person or the housekeeper, right? Or whoever's taking care of the property while they're in the room, the employee. OSHA's taking care of them. Okay. NFPA, they adopt NFPA, but NFPA is done there to protect the public, right? Okay. So, so I'm gonna have a different map for you just to kind of show you some examples of discharge and maps and everything else. Let me give you an example actually in here right now. Okay, you see where you see all the arrows going all the way around. Anywhere where you see an arrow going around, that's the exit route. Okay, that's the exit access or the exit route. Anywhere where you see the arrows, you see where y'all see where the stairwells are right in the middle. Yeah, on page 33. Okay, those stairwells, those are going to be the actual exit itself. Okay, because those have fire rated walls, right? They're going to have, if it's 3 stories or less, they have to have at least a 1 hour fire rated wall. If it's greater than three stories, like 4 stories or more, it's going to have at least a 2 hour firewall. Okay, that is the actual exit is the stairwell, whether it's in the center of the building or adjacent to the building. The exit discharge is the door. The discharge is what's getting us out of the building, which we normally see. Okay. Now, as far as NCCER, they don't delineate, but OSHA does. Okay. All right. So let's move on. Right. As y'all see, some of these topics are getting a little bit easier. We're going to save GHS. I don't. We're not going to have time for it tonight, and I'm going to save it because I really, really, really want to spend some time on it. Okay, because I think it's one of those places where we all often missing. We're often missing, so I want to make sure that we meet that mark on it. Okay. All right. So tools, right? Excuse me. Using the right tool for the right job. Bladed tools. Let's talk about the bullet points, right? Following the following hazards are associated with tools. Using the wrong tool can be dangerous, right? Using a chisel, a screwdriver, are things that we know, right? Always maintaining tools properly, right? If it's a wooden handle on a tool, like an axe or something like that, it can be splintered or it can be cracked. Anybody out there is allowed to use wood tools still, or is everybody using fiberglass handle and metal handle tools? Let me know if y'all still allowing employees. I'm not talking about brooms and stuff like that. I'm talking about impact tools like hammers, chisels, items like that. Is everybody pretty much requiring? Yeah, fiberglass. Yeah, a lot of fiberglass, right? Composite and metal, right? Okay. All right, good. Okay. And then, repair or replace worn or damaged tools, right? And then, like I said, impact tools like chisels, wedges, drift points are unsafe if they have a mushroom head as well. So obviously, we want to be careful, pull anything that's got a mushroom head out of service because it might slip, it might have projectile from it. Okay. It could come into all kinds of different hazards like that. Okay. And then bladed tools, right? They always pose a risk. We want to use bladed tools with blades and points aimed in the right direction away from ourselves. Don't cut towards ourselves. direct bladed tools away from the aisle areas also, you know, to make sure we don't cut anybody else that's coming walking around. Store bladed tools properly. Use the sheath or the protective cover and form. I'll give you an example. Let's use a drywall knife, right? Cover. Drywall, excuse me, saw cover. I'm looking for the individual pouch. I'm looking for a drywall saw like that, either safely stored somewhere. A lot of them will come with their own like knife pouch, and go ahead and make sure that they get back. Let me see. Here you go, right here, perfect example. Best to put it back in a pouch, okay, a protective pouch like that. So hopefully you have one that's in a pouch if you're using it. Okay, not all of them have a pouch though. Okay, so just watch them. Let me ask you a question, folks. Give you a quick question, and then y'all, I want you to answer for me. And I think I might have asked y'all this already. Name a hand tool. I think some of y'all might have heard this already. Type in a hand tool right now for me. Still missing a couple. Come on. Got to send it in. Okay. A lot of y'all are slick, huh? All right, folks. So here's the difference. Hand tools are manually driven. Power tools are driving by power like battery, air, hydraulic, okay, electric, any of that. So I had a couple of screwdrivers on there, and I had a couple of saws on there. I know y'all are talking about those old manual saws and those old manual carpenter screwdrivers, right? I mean, not screwdrivers are drills, huh? Talking about the old carpenter drill. Let's see. Talking about one of these, right? Just want to make sure. Okay. All right. So look, let me tell y'all, it's one of those things, right? We use them interchangeably all the time. I'm gonna tell y'all, I had a guy in my class. I was doing his refresher for OSHA. I don't know, general industry construction refresher about 3 years ago. Got busted out on this. I had a big old smile on my face, and he asked everybody to say a tool. And what I tell him, I told him an angle grinder, right? So you think he didn't have fun? Not angle grinder, excuse me. You think he didn't have fun busting me out for me, the instructor, telling him that this was a hand tool? Okay. So it's great. I got to tell you, because what it does, it makes us remember, right? Manually propelled are hand tools, all right? Okay. So then on the right hand side, right, different identification of different tools, right? Hammer, you square up at the upper right B. You know, any type of vise. A lot of times you use those for cabinets or to hold members together, while maybe you screwing them together or tightening or gluing. Screwdrivers, drywall saw. Okay. Next page, right? You got a bunch of different types of bladed tools there: scissors, nips, pinches, right? As y'all know, I don't know how familiar some of y'all are. I don't remember the color codes, but you got yellow, green, and red. I think red is right, green is left, I think, and then yellow center, straight ahead. So those nips, depending on the color, one will cut to the right, one will cut to the left, and the other one cut to the center. Okay. And then you got punches, you got wedges in there, right? You got your chisels, you got your hacksaw, you got your wood saw, all right, your utility knife, right? And so you have all different types of tools there. And then what are we talking about, right? Minimizing hazards. What hazards are we trying to minimize? Cuts, burns, scrapes, sprains, eye injuries, right? Hearing loss, broken bones, right? Pulmonary disorders like lungs and stuff. So different hazards that we're looking at, okay? And then proper use of the tools that we're using, right? Power tools. And what are we talking about power tools? Power tools, we're looking at electricity, right? Pneumatic, air pressure, liquid fuel as well, and then hydraulic, just to name a few, okay? could be cordless as well. They don't have it in there, but cordless tools as well. And then if you go to page 38, now we're looking at a receptacle, right? The receptacle, the ground plug in the receptacle is going to be the neutral. Oh, excuse me, the ground. Isaac, which one's the hot and which one's the neutral? Left or right? I got a ringer on the line, y'all. So I'm gonna get some help in this one. So let's see. Yeah, the bigger one's neutral. Do you remember which one? Here you go, folks. For anybody who's not familiar, okay, is let's see. Okay, the bigger one's the neutral right here on the left, y'all. You see how this one's bigger? This is what's going to happen, right? This is ground. This is neutral. This is hot. So anytime this receptacle is wired now, let me see if I can find one that's wired, right? Here you go. You see? Can you see the small one on the right-hand side? It's got the black wire and the gold terminal. Okay, that's the hot. The neutral is the white wire, and it's going to be a silver terminal on this side, and then your ground is going to be either down here or up here, depending where it is on this one. Okay, y'all got it? I'm good with that. If you ever need it, you know how to look it up, right? Okay, good. Okay. And then, okay, so let's see. You can see it here. Silver, right? Neutral side, hot side, gold. And then there's your ground wire. Okay. All right, good. Okay. And then look at your upper top right, folks. I don't remember any of this being on the test. I just want you to know it's there. There's a different formation of your plug and your receptacle, right? For 15, 20 amp, 30 amp, and 30 and 50 amp. Okay. And that's how you can delineate. And then the voltages as well. Okay. Normally what we're used to is going to be either as 15 or 20 is what we're used to seeing, maybe some 30s from time to time at 125 volts, okay, like trailers, stuff like that, okay? And then your washer and dryer or something like that would probably wind up being a, it would probably wind up being something like a 50 amp, like a 50 amp 240 or something like that, like 250, okay? So is that right? Which Isaac, what's your dryer? What's your electric dryer? It's going to be 240, right? Or 250? For an electric dryer or an electric stove, usually going to be a 50 amp, right? 30 is not enough, right? It's going to be a 250, 50 amp. Is that correct? Okay, good. Okay, folks. So electric dryer, electric stove, your plugs are going to look. Now, what happens is now they have a 4 wire instead of a 3 because they have a hot, a neutral, and a ground, okay? So it actually wound up being a 4 wire plug. So let me show you what it looks like now. So let's see. This is what the old one looked like this, folks, the 3, okay? And then this is what your newer ones look like now, which is a 4, okay? And the reason is that you have a hot, a 120 and a 120. That's what a 125 and 125. That's what gives you 250. And then you had a neutral, okay? And then the back of the receptacle would be grounded out. Now you actually have a hot, a neutral, and a ground, okay? So now it's a 4-plug receptacle, all right? If you have a 4-plug receptacle, y'all, you have to have a 4-plug whip. So if you get a new dryer that needs a 4-plug receptacle, because it has a 4-plug whip, you're going to have to get a 4-plug receptacle. Don't pull one of the, it won't even let you pull the ground out. Okay? All right. So, and then we got air tools, right? Pneumatic tools. What do we have? Drills, right? Nail guns, okay? Chisels, saws, right? Depending. Got a lot of different type of air tools or pneumatic tools out there now. If you look at the next page, right, jackhammers might be air as well. And then you got your connectors there. These connectors that we're looking at there, those are called those are called, let's see, those are air connectors or pneumatic. One thing I want, they're also called positive lock. They call them positive lock, and this is why, is that you have to pull this piece back right here. It's spring loaded. You pull it back, okay, in order for this piece to come out of it, okay? So these are 4 males. Any of these males would fit in here. They're probably all the same size. That's a female. There's your male. Right here is a perfect example. You pull the spring load back, and it'll pop out. If it's got air pressure in it, be careful because it can whip on you, Okay. Now, this is what happens is you notice the whip check in the it's called the whip check. Okay. That whip check right there, it's not required on positive lock. It's required on simple lock or single lock, and I'm gonna show you what single lock is. This is positive action because it has dual purpose, right? You have to push down on it in order to get it out. Okay. Now, if anybody's not familiar, and this is probably where we're going to start winding it down for the night because of the time already, we're going to just save the very last bit. I'm going to ask you to read a couple pages. We might try to just push through maybe about another 5 minutes and let's see what happens, right? Then I'll ask you to read through it while you're over between now and Thursday or over the weekend. What happens is it's called a crow's foot fitting. Some of the refineries will not allow this. Okay, you always have to have on these fittings. Anybody seen these fittings out there on old air compressor hoses and stuff? On these old crow's foot fittings, y'all, you have to have a whip check. Okay, you have to have a whip check on these old crow's foot fittings. Okay, the reason being is what happens is they turn into place. You put a cotter pin in them, right? You have like a male female. You tie them together, twist them, and then you put a cotter pin through them. Okay, but you have to have a whip check on them always. Okay, now the new preferred method. Some facilities don't even allow those anymore. Now what most facilities want is like a cam lock fitting, or cam lock hose fitting, which is this. Okay, now you have to flip it down one side, flip it down the other, and you still put pins through them. Okay, so once you flip it down, you'll see the hole there, and the hole is to not let the levers come back up. Okay, so these are you see them a lot nowadays. Anybody who's around environments where you're pumping, maybe from vessels, right, or above ground storage tanks or anything, temporary pumping, these are the kind of cam lock fittings that they're using. Okay. So just so you know, so they sell them small. Like some of the Exxon facilities won't even allow crow's foot fittings. The funny thing is they wouldn't allow them with the contractors, but they would still allow their people to use them. Okay, so so obviously they saw a significant risk with the contractor, but they felt that their policies were a little bit better or stronger in place. Okay. All right, so then chainsaws, right? Liquid fuel tools, items like that. I just want you to kind of read over that for the next few days. We got your hydraulic jacks, right? That hydraulic jack that you see there, you'll see the little, let's see, fill-in hydraulic jack. If this jack starts to lose pressure, you probably got a bad seal, but probably what it is, you're probably low on oil. What happens is you pull the little screw out, okay, the little screw that you see on your picture on the one in the book right there, that little screw right there. You fill it up with don't fill it up with oil. You got to fill it up with the right rated hydraulic oil. Okay, it's not regular oil, not regular motor oil. All right, and that's what gives it its pressure. Same thing goes with floor jacks. If you got floor jacks that aren't working adequately, you go ahead and same thing. You go ahead and pop off the little fill, and you go ahead and fill it up as well. Okay, there you go. There's a picture of it right there. Okay. And so it could be a floor jack or it could be a hydraulic jack, right? That's one of the greatest hazards. If you have a jack like that going down, it might not necessarily be bad. You probably just need hydraulic fluid for it, okay? And then let's go ahead and go to the next page. Things that you want to do, right? Always having eye protection on, right? Always match, with a grinder. Always matching the RPM to the grinder. I'm on page 44. Turn the power on and off of the grinder, when it's not in use. So always turn it off, leave it off. Okay, you don't use the grinder around flammable areas. So let me tell you, you got a picture there of a DeWalt grinder. Let me show you one of the handouts that we're putting together. I know some of y'all signed on late today. What you saw when y'all came on earlier was all the answers to these sections in this book. We're sending these out today or tomorrow. By the end of the week, you'll have the ones for the orange book, and we're starting to send handouts out. We're starting to send it to you via email, and then we're going to send you bundled packages with all color printouts, so you have them to review probably in about the next week or so, okay? I'm going to follow up with all y'all by email just to make sure. I think I have everybody's mailing address, but just to have it to make sure that we can send it out. Like I said, I'm sending them email and then send them out regular mail for you, okay? So let me show you grinder checklist real quick, folks. And this is what I'm going to show you. This is something that we'll mail out to you in the next couple of days also. Is this grinder checklist right here. This is straight from OSHA, y'all. It's all in the 1910 standards, okay? The only thing that there's a letter of interpretation is right here where it says, are fixed or permanent mounted grinders connected to the electrical supply with a metallic conduit or other permanent method. It does not. There's a letter of interpretation in the OSHA standard that says that if it's an SO cord and if it's an electrical rated cord, right, an SO cord, and you use it and clean behind it on a regular basis or potentially move it, it does not have to be in a metallic conduit. Okay, that's for any power tool. Okay, and that's in the electrical standard. Actually, I'm sorry, that's not the one I'm gonna send to you. The one I'm sending to you, I don't want you to have to do any work. Is this one right here, y'all? And it's got all the OSHA standard numbers on it already. And like I said, there's a letter of interpretation attached right there to that one that's saying that you don't always have to have it. Okay. All right, guys. So look, let's do this, everyone. Let's stop it there. We'll pick up with grinders and power tools when we come back. Close out that chapter come next week, and then we'll hit also the GHS HASCOM, and then we'll probably even get into module 2. And I don't know if we're going to finish module 2 next week, but we're going to get into it at least. Okay. I'm trying to do module by module, but I'm going to see where this leaves us for next week. It was just, I told y'all, I figured this was going to take us 2 days. We really got a lot further than I anticipated, so I'm happy with it. Anybody got any questions? Anything you want to add? Any questions? Any comments? Any corrections? Any lottery numbers that I can play for tomorrow night? Anything? Okay. All right, folks. Well, look, everybody have a great night. Thank y'all very much. All right. Like I said, just look for your emails in the next today, tomorrow. I'm going to start sending y'all out. Thank y'all all. Appreciate it. Okay. Start sending y'all out the answer keys. I'll probably send you an answer key right now for the back of the book of this. And then look, for anybody who came on late, page 67 has all your answers for the green questions. Okay. So for module 1, you have all the green question answers on page 67 and the standard section reference where to find it. And then let me show you one last time, just for anybody who missed it. This is the one I'm sending you out. Not that one. Hang on. This is the one that I'm going to send you out right now, everybody. And this is the answers. If you go to page 50, I think it's 59. Let me see. Page 50, 59 and 60. These are your answers right here. Okay, in this column. This is the reference on where to find it if you want to find the answer, okay? So that way you've got all the answers. When I send you this tonight, you're going to have all the answers for this whole brown book, okay? All right, y'all, reach out to me, call me, text me if you need anything. I'm in a 510 all week, but I'll be glad to call you back on a break, okay? It's best to text me. Y'all know that. And then if not, if I don't hear from you, this is the link we'll use on Thursday again. We'll use this link through the end of January and probably into February, hopefully, too, okay? Y'all have a great night, folks. Thank you again. Bye.